So how do I use the remainder theorem to find a value? So what you're going to do is you're going to do synthetic division. Okay. You know what? We're going to do something a little different here. I'm going to evaluate. I'm going to plug in -4 into this here. I don't know if this is good teaching or not, but we're winging it here. We'll plug in -4 into the function. 4 times -4 squared minus 5 times -4 plus 3. And so it's -105. Keep that in mind for later. So it's -105. Okay. I'm going to write down my coefficients. So I'm going to do synthetic division. Make sure you're not skipping any powers. Make sure these are in the right order. They are. And then I'm going to do synthetic division. So remember synthetic division. Next step is you bring down your leading coefficient, which is 3. You multiply this with this value here. Now, you don't change the sign on this one. You're just going to keep it as -4. I know that gets a little confusing. When do I change the sign? When do I not? You just keep it as -4. -4 times 3 is -12. Okay? And you add 4 plus -12 is -8. Multiply -4 times -8, 32. Add, that gives me 27. 27 times -4, that would be -108. Okay. 3 plus -108 is 105. Now, what am I doing here? Well, notice that when you plug in -4 in there, you get -105. So what does the remainder theorem says? The remainder theorem says whatever your remainder is going to be the solution for the, it's the same as when you evaluate the function for that input value. So basically, using the remainder theorem means you do synthetic division with this, with -4 to this polynomial. Whatever you get for your remainder will be equivalent to what that polynomial would be if you plugged in -4 for its x. Now, if it was me, I would think, I would just go ahead and do that. But just the remainder theorem just shows you an alternate way to do it. I'm going to write down this as well, just for teaching purposes. -4 plus 3 equals -105. So you see how these are the same. So your answer is your remainder.